Okay, in this video, we're going to talk about how to code race variables in the American Community Survey to more useful way. So I'm going to do this in Stata and use ACS 2018 5-year sample. But you can easily do the same thing in R code as well. Here, first thing we're going to look at is what the race variable that EPUMS generates as is. And mind you, this has 3 million records. So if you're going to do this, just keep in mind that it takes a while for Stata to run. So here, what you see is you have these race categories. But behind this is obviously the numbers that correspond to each race category. So here, for instance, 1 is white, and 2 is black / African American, and what have you. So given that that is the case, and then we have another variable that we need to pay attention to, and that is Hispanic. And Hispanic is a sort of this dichotomy of yes or no question that is a little more expansive here in Hispanic origin, but that's something to keep in mind as well. What's really important in Hispanic variable is this non-Hispanic versus all other categories that are part of Hispanic. So here, let's say you want to generate what we commonly refer to as non-Hispanic white. So we're gonna begin with coding everyone, generating the variable and giving everyone the value of 0. You could easily use the recode function in Stata, but I like doing it this way because you can check your work a little bit better. The code, I think, is a little clearer this way. So if you do these 2 lines, generate non-Hispanic white, in fact, label this new variable white. Then let's look at the variable with the weight. So there's a weight in the sample file, so we can see what it looks like if you apply the weight. So first it generates this variable, and then we're going to replace that variable whenever it encounters the original variable race at the value of 1 and Hispanic value of 0. 0 was non-Hispanic. So if you do that, it will create what we normally would call non-Hispanic white. So here, because we apply the weight, instead of 15.8 million in our sample, it will give us the figures based on 322.9 million. That was the population of the United States at 2018. So you can also do essentially the same thing for each race category. So if you want to generate non-Hispanic black, for instance, you can essentially do the same, and you can also apply the weight the same way. And so on. So here, what is a little distinct, so we have about 61% of US population was non-Hispanic white as of 2018, about 12.3% is non-Hispanic black. Well, what is really distinct is mixed race. So if you go back to the original variable here, 2 or more race, 3 or more race. So you have values 8 and 9 that make up what we commonly refer to as mixed race. So you can generate a new variable, mixed race, and then here what is different about mixed race is that race will be greater than equal to 8, so it captures both 8 and 9, and then Hispanic being 0. So once you do that, you have a race category that we would call non-Hispanic. We'll apply the weight just like we did for other race categories. Obviously, you can do this for non-Hispanic Asian, non-Hispanic Pacific Islander, and so on. So it should be 2.4%, which should make up, if you go back and check the work, it should be about, here it's unweighted, so it's about 3%. It turns out if you apply the weight, it is about 2.4%. So that's how you code the race and ethnicity variable interaction between the two to create non-Hispanic white, non-Hispanic black, and so on and so forth, which is our convention in using race variables, using the census data.